Welcome back, friends. We are into 31st module. We have already looked at from the physical layer to the application layer, all layers, and we have seen that they are just great. The journey was great about learning about all those layers and how they function and how a complex job is being managed. But there is a trend. In fact, subsequent 6 lectures we will be talking about 2 different trends which has changed the entire world and is going to change. In fact, there is going to be a huge impact on these two things. The first thing is called software defined networks. We will be talking about that from this module. We will be talking about SDN for 2 more modules afterwards. Software defined network is a way of looking at the network from a very different angle. You would like to control the network by software. So, you won't like your switches, different switches to be managed personally, going there, changing a few things there, hardware part, and manipulating switch or a router using that router's own language. For example, if you are working on a Cisco router, you will be using that language, or Linksys router, you will be using that language. Some routers run over Linux operating system. So, you need to know how Linux works. So, that kind of a scenario is very common. The software defined networking changes everything completely. You will not have that kind of a system. Now, the switches are reduced to something called forwarding devices. You have very different segregated control plane where you work on, an administrator will work on that plane in an abstracted manner, will be writing his own rules and policies about routing, and we are not confined to layer based IP TCP based routing. We have hinted about that while we discussed about MPLS and packet classification. That kind of a vision is extended in SDN. Okay. So, you have a different plane that is separated. Now, administrators are working at a higher plane and switches are their hardware, but basically managed all by software. So, that is the thing that we are going to look at in this particular module. We will in the beginning, in the first module, we will be looking at what are the needs and why the world is being driven towards software defined networking. This current networking solutions have worked for many years, 30, 40 years now, and they are doing fantastically well, and why you need to upgrade to or change to SDN is also quite interesting. So, we will try to answer that question during this module. Okay. So, SDN is having increasing popularity in recent years. One of the major reason is that administrators wanted complete control over the routing process. Okay. For example, here are few examples. An administrator would say that like to apply AES for encryption and a specific protocol for authentication across the entire network. I do not want any router to escape from it. Second thing, all voice over internet protocol communication sent over a specific path in the network, all of them will travel through that path only. Not only that, I would like to have routing based on customer, okay, 2G 3G customer, which I have already talked about in past. Move a 4G customer to 2G once he consumed this quota. Okay. So, now this is an interesting, this is called exception. A 4G customer is given 4G treatment, but when he consumed his daily data of 1G or 1 GB or whatever, he is now converted to 2G. Okay. So, that kind of exception is also possible with SDN. Offload work of one switch onto the other, and this has to happen in autonomous way. When one switch is overloaded, other switch can take over some of the load. Okay. Not only that, the latest vision about customer that they would like to have network as a virtualized product. They are just connected to internet. They say that I want 10 switches and this, that, and that is available over internet. Okay. That is called virtualized product or network function virtualization. Okay. The second thing is administrators need tighter control. Tighter control because of some recent trends, like first trend is called BYOD or bring your own device. Here people like employees bring their smartphones, their laptops, even students bring their smartphones, laptops, and all of them connect to our network. So, when our foreign objects come and join the network, adds a lot of burden on the administrators, and they would like to make sure that they answer problems caused by this thing. They want to have tighter control on devices which are coming from outside. Everybody can now connect to cloud and run and fetch application and get data from it. This makes it, in fact, these things may be great for a user, these are nightmares for administrators. They need to solve this problem actually. The other is other thing which is happening is called big data. There are a lot of data coming in with variety and velocity, speed with which the data is coming. For example, social networking data is coming in. Now, you will have to manage the huge volume of data here. There are distributed databases where the data is stored at multiple places and they coordinated together to solve a problem. Now, these things demand tighter network controls. There are a lot of high speed networks with huge data demands on the rise, and very complex policies are to be managed, and the policies are not confined to IP addresses. The policies are based on administrators wishes or the organization needs. For example, nobody should be able to access any mail account during lunch hours except lunch hours or something like that. So, such policies are to be managed, okay. And we will be talking about that. Network resource management has become more critical. For example, switches should be able to route properly despite load differences, okay. So, that is one. So, you demand better switches. Not only that, when one or the other server is facing a load and receiving a pump or pumping more traffic in, allocate switches on demand. Now, this is something quite interesting. Assume you have two servers, one server here, the other server here, both of them are capable. And if one server is receiving more load now, more network resources are allocated to that server. Afterwards, if this server starts receiving more load, this server should have more resources, network resources allocated to it. Point is, network resources should be allocated on the fly as per need, as per the policy of administration. So, that is another requirement. Okay. Not only that, you should have a single consistent interface for all devices, and I have talked about that. I have some Linksys switches, I have some Cisco switches, I have some other switches. In fact, in case I have 5 different types of switches in my organization, I have to learn 5 different interfaces to deal with those switches, to manage those switches. Okay. And that is not very good. In fact, it is better if I have a single consistent interface with which I can manage all types of switches. That is better, and that is what is the need of the day. Okay. Not only switches, but then there are other things called middle boxes. For example, there is something called a firewall which disallows traffic. There is something called intrusion detection system which looks at the traffic and find out if there is a malicious traffic. There is something called load balancer which looks at the traffic and find out how to balance that traffic, okay, and so on and so forth. So, there are proxy server is another example. We have looked at the proxy server earlier when we discussed about HTTP. So, point is we need many devices, and we, in fact, if we manage every device as a single different entity, we need to have a separate interface for each of them. What we need is a single consistent interface to all of them. Basically, all of these devices are packet crunching devices. There are some packets coming in, they process and forward them. Switch actually look at the data and decide where to forward. Proxy server looks at that thing and establishes TCP connection and send it over that to that web server. Intrusion detection system will look at the content of packet and decide whether to drop or forward that packet. Firewall also does the same thing based on, but it looks at other information and decide whether to forward or drop the packet. Point is, everything requires similar treatment. Okay. Incoming packets are to be processed and forwarded based on some rules. So, why do not we have a consistent single interface? That is the point, that is the need of the hour. Okay. So, SDN provides that network resource sharing as well as traffic engineering. We have looked at traffic engineering in past. We would like to manage the traffic in our own fashion, and the solution must be the here are few characteristics which are very critical, vendor neutral. Okay. So, I might have 5 different types of switches, but then the interface should be different. The interface should be consistently different than them and a unique interface. It should provide a centralized control. I should not go to every switch and configure that switch, but sitting at a single place I should be able to do it. And finer admin level control, I should be able to not only look at destination address and route, but I should be able to do many other things. Older solutions to this problem, one was known as overlay network. Overlay network is basically a virtual WAN, is an additional layer on top of the existing network. So, you have existing network on and on top of that existing network you have this overlay. Now, administrators actually talk to this overlay and overlay talk to this network. You will almost get almost everything that we discussed about, because that abstraction layer, that overlay provides us that kind of service. For example, if I have 2 different networks and I have defined 3 different groups, lab 1 and lab 2, and I have 3 groups, faculty, student and operator, I can actually look at that and I can actually allocate machines, I can define rights for these 3 groups irrespective of what is underlying. Okay. So, the overlay actually manages that thing for me, it will show me 3 groups and map those 3 groups to 2 labs. Okay. So, that is an example of overlay. The other solution is called virtual private network. Virtual private network connect 2 endpoints in a secured fashion. Okay. So, but then you have a control over how that is routed. Okay. So, you know exactly what is the path. Okay. So, VPN can use to communicate and provide you the exact path in a secured manner. Okay. Before we proceed further, let us try to understand what are the functions of networking devices. We have already seen routers and we know that what routers do, but now we are going to talk about 3 different things normally a router or a switch is expected to do. The first part a router is supposed to do is to route. Okay. We have to talk to others and get that routing information, that is the first job. And for example, if I have deployed link state, I will have to actually tell the router that you will have to use link state algorithm. I will have to install that. I will have to sit on the router, install that algorithm, run that algorithm and make sure that router is running that algorithm. So, that is the first thing that I am supposed to do. Second thing the router is supposed to do is to forward incoming packets. And there is a third thing, you probably have not understood it, but the third thing is, so remember 2 things. First, runs link state algorithm, okay, that is first. Second, forward a packet. Third one, provide an administrator like me to work on that switch and provide this information, like I would like to use link state. Router may provide me an option, say would you like me to run link state or a distance vector, or the first version of it or second version of it, and I can choose. In fact, based on my requirement I can choose. I can even allocate some memory for it and so on and so forth. I need to interact with router to get this job done. That is the third job of a router. It should provide me an interface for getting this job done, and that is the third thing, which is called management plane. The forwarding part is known as a data plane. The controlling part, the link state algorithm or whatever that manages that routing process is called the control plane, and the management plane is one which is the interface. Okay. Okay. So, you can see that forwarding network traffic is one, deciding to treat different traffics differently, okay, that is the routing. And remember, it can be depend routing process to be designed as per need. So, whatever OSPF or whatever. It can also be based on packet classification process, which is independent of layers. We have already discussed both of them. And it should also provide a configuration interface for us for network wide management process. Okay. So, I will have to do it. The first two should be separated, and this is the idea of SDN, that this should not be together, and I will see why it want that. Third, the management plane is to be provided in open fashion. Now, let us try to understand all this, why all this. Okay. This tight integration in conventional switch means that both data and a control plane. Remember, data plane is the forwarding part, control plane by default is routing part, but it can even be the packet classification process. Packet classification is control plane decides how packets should be classified, and data processes incoming packets and decide how that process is done. Okay. Because both of them are part of same switch, they have direct communication, they talk to each other, they remain in sync and results into far better performance, because they do not need to do anything else, they will have to work together, they are there together, they will work together, that is the reason you will be able to get a far better performance. Router is acting as a single unit, okay. Both of them are combined, router is acting as a single unit and provides services to other units. Okay. And if there is some faulty configuration, if the routing table is falsely configured, that will not propagate further, they will confine to the device itself, and the malfunctioning router can be easily isolated by administrators and can be managed. Okay. So, that is the advantage, and all devices are self contained, they get everything that is needed for them, and that is one of the best things that we have. When we have a self contained device as one of the components, we can always extend the reach of the network by increasing number of such devices. So, that is the other part which is good. But then recent years we have seen that this tight integration is causing us problems, and we have in fact, I have already hinted about some problems. The problem number one is when you are using heterogeneous devices, each one of them will give you a different interface, and you will have to learn that interface if you want to work with them. Second thing, no longer are we using the destination based pure IP address based routing processes. The administrators demand more policy based solutions, which is very hard to implement in this model, because you will have to go to every switch and configure that yourself. You do not sit on a single place and do everything together. So, that kind of a solution is demanded, but we do not have, and especially when there is a large network, if you want to provide such a solution, then it is very hard. So, that is the other issue. Okay. Devices are individually and manually configured, you will have to do that, and you cannot have well planned systematic process, it is impossible. Okay. And some common issues, when you individually configure a switch, one switch after the other, the problem is I have hundreds of switches, and I configure first switch, then the second, then the third, then the fourth. It is quite possible and human for me to make some mistake doing so. When I make some mistake doing that, what will happen? That switch will start malfunctioning. What the result? Probably there are few results. One is that switch will loop the packet. For example, the path is switch 1, 2, 3 and then receiver, the switch 1, 2 and 3, the third switch, instead of giving it to the receiver, passing it to switch 1. Switch 1 when receives that will give it to switch 2, and again when it reaches switch 3 will pass it back. So, it is kind of a loop generator, my packet will not reach the receiver, that is called loop, that is the first problem. The second problem is when there is a service level agreement, that one customer who is a highly ranked customer and who is paying more, and we know that I have 10 GB bandwidth, and out of that 5 GB is given to that customer and 5 GB to rest of them. Because of this malfunctioning, this misconfiguration, the customer that should get 5 GB should not get, may not get 5 GB. So, when that happens, my service level agreement is not complied with. So, it can have serious consequences over business. So, such things are happening, and devices may start malfunctioning, and you will have to find out and pick up, and individually you will have to find out, go there, individually configure that switch. These are the issues with this tight integration, and that is the reason why SDN demands it to be separated. Okay. Here are two other approaches, virtualization and overlay networks. Virtualization is very common in internet. The TCP itself is provides a virtual service, when TCP for example communicate with application, application says I want to send that mail for SMTP, for example SMTP says this is the mail, you should give it to obs.com, and TCP obliges. TCP, how TCP does, we have already studied it, it takes lot of pain getting it done, but the application is just completely unaware about it, it just provides that mail to it and gets the response. Okay. So, that kind of solution is very needed in this case we need a solution of that type. Okay. So, that is called virtualized environment. Overlay is the other one I just hinted about. Overlay is a network on top of network, it is kind of a virtual WAN which runs on top of the network, and as a user you won't actually interact with the network, you interact with the overlay. Okay. An example is shown on the screen. Okay. Here is a central office and of a typical educational institute which has 4 centers, one is Nadiyad, another is Anand, Mehsana and Vadodara, all 4 places of Gujarat. Okay. And they have, each one of them have at least 3 divisions: accounting, academics and student. Okay. So, each one of them have these 3. What the requirement now is that each one of them can communicate with central office. Now, they are not directly connected, they are connected through internet. The requirement is that each one of them should directly communicate with central office for submitting their mark sheets, they are academic institutes. So, that is the first requirement, and in a secure fashion, that is the first requirement. Second requirement is the accountant should be able to talk to each other, but none others should not be able to talk to the accountants. You can see that the physical structure of this thing is that accountant, each case of accountant division is part of this network. Okay. What we want is a logical separation of accountants from rest. So, that is done by something called overlay 2, and overlay 1 connects all of them together, and in fact, there is an internet in between, but overlay 1 hides that thing from us. So, that is called overlays. So, overlays can be quite useful. The advantage of overlay is you can have secure connection between centers using some tunneling protocol. So, overlays does that. For example, if student here is communicating, a student is communicating to central office, there is a tunnel established between these 2 points in the internet. So, as if these 2 things are communicating directly. Okay. Same way this accountant is talking to this accountant, again a tunnel is established. So, that kind of a solution is provided. Okay. Virtual private network is basically a protocol for tunneling, and it does using security also. So, it will encrypt the data as well as provide authentication. Okay. The other thing which we have stressed many times in past also, and again an important theme for SDN is to routing based on quality of service parameters and not merely on destination address. Okay. And traffic engineering, we need something called flow based routing, and you can consider 3 different flows for a normal ISP: 2G, 3G and 4G. Now, these are simple examples of flows. So, I would like to route all 3 different types of customers separately. So, I can consider 2G as one flow, 3G as one flow and 4G as the other flow. Okay. So, flow based routing, it is not based on destination address, but flow. Another example is customer based, a gold customer, silver customer, whatever. Third example is business relations. Okay. So, I have designed some business relation model. For example, with one organization I have an MOU that every 1 GB that I pass, he is 1 GB, he should pass my 2 GB. With second organization I might have an MOU that every data that he is sending me, for every 1 TB he is paying me 1000 rupees. Okay. The third case is the amount of data that I will pass, that amount of data he will pass, and if any excess, for every 1 TB the other party will be paying 1000 rupees kind of. Okay. So, it reflects that business relationships or MOUs that exist between organizations. and this solution should reflect that thing there. Okay. So, here are some examples already given. Here is one simple thing which I have designed to show one typical requirement. One say here I have two different types of packets, VoIP and data packet. I have same sender, same receiver, but I want VoIP traffic to travel through a shorter path, only 3 hop path, and data traffic can travel over a longer, but maybe with higher bandwidth. VoIP does not demand large bandwidth, but it want quick delay. Okay, it should be delivered quickly. So, example VoIP take list hop, you can see that it travels here, and data packet takes this route. Okay. Same sender, same receiver, the paths are different. This is the need of the hour. This is what we want our routing algorithms to provide. The routing algorithms that we have talked about so far, link state and manners and all that, won't provide this. Okay. So, connection oriented networks and routing overlays are two things which solve this problem. Flow based routing provided using these two approaches. Okay. Connection oriented networks, connection oriented networks means you establish connection beforehand. So, every switch in the middle agrees to what we want, and then we will establish the connection, otherwise we will not establish the connection. Okay. So, that is very critical here. So, once you know and you know that this is the path is going to be followed, we can establish two different paths to same receiver, one for 2G, one for 3G, or one for normal traffic, one for VoIP traffic. Okay. So, that is possible using virtual networks. Even overlays can do it. You can define two different overlays, one for this traffic, the other for this traffic. The implementation of overlay should be such that the overlay which demands faster delivery should be modeled using short distance routes, and the overlay which actually implements data delivery, reliable delivery, should travel through the other path. So, that also is possible. So, routing overlay and connection oriented networks both can be used, but the problem is that connection oriented networks they are fast, because in fact connection oriented usually they use hardware, packet classification and all that. So, that process is very fast. Unfortunately, because there is a hardware, they are not all that flexible. Overlays are very flexible. I can omit a node from the overlay with a single click. I can change the overlay in few seconds when my business relationships change. So, overlay is quite adaptive, quite flexible. The problem with overlay is that they are not implemented in hardware, and obviously there is an additional layer over the network. The network is anyway slow. Nobody has ever found a network which is fast enough for his own need, however fast the underlying networks have become. So, it is always slow. So, and you run an additional layer on top of which makes it slower, which is not acceptable to many of us. So, both of them have pros and cons, and that is what we have discussed. The overlays have obviously a pure software implementation. That is the reason why they are all flexible. Connection oriented networks have some part which is hardware, and that is the reason why they are faster, that packet classification part. Okay. Here is again an example which people want, okay, the designers want. We have already seen the router architecture in past. In router architecture, we have input ports, switching logic and output ports. Here we have an additional part having multiple queues. Okay. So, packet 1 and packet 2 both are designed for the same port, but they will go to different queues, and it is quite possible that packet 1 arrives before packet 2, but packet 1 goes to Q 1, packet 2 goes to Q 2, and Q 2 has higher priority. Okay. So, packet 2 will leave Q 2 before Q 1. Now, you may be surprised why you need something like this. Okay. If packet 2 is a VoIP packet, so VoIP packet, what we want is we want a better service for that. Here that service is possible to be provided. Maybe there are hundreds of other packets come before this thing and are enqueued here in this Q 1 packet 2 will not wait for any of them, will join queue 2, and if there is no other packet, will leave the queue before any of the data packets do. Okay. So, you will give higher priority to the traffic that you want. You can define different queues and you can provide different priority to that traffic. So, that is the power of this mechanism. Here is some more difference between connection oriented networks and routing overlays. Okay. Routing overlays, as I said, provide dynamic control, you can change as you wish, but they are slower in operation. Okay. Overlays can help converting existing network setup to act as per administrator's choice. You do not need to change the network, the overlay run on top of it. Okay. So, that is great, but it is very slow. Okay. Can change if the MOU changes, which I talked about. Multiple overlays for different type of service can work together. So, if I have just seen an example where we have two overlays, one overlay is helping different centers communicating to a central office, and the other overlay letting all accountants communicating together. So, it is possible to have multiple overlays. In fact, it is also possible to have multiple overlays which are overlaying. In fact, they have common members also, that also is fine, all that is possible. Okay. So, that is the power of the software driven approach. The only problem is that they are pretty slow. Okay. Can be norm optimal if underlying physical links change their load, that is the other problem. The overlay is basically mapping to the physical layer, the physical network, not physical layer. So, if overlay, they have designed their own path based on the physical lines connected when the overlay was established, but we know that this physical lines, physical connections completely change after a period of time, it is quite possible. When that happens, in the conventional network, the routers learn about that and change the routing paths, but the overlay is something which is an abstraction on top of which is working on its own. So, it will not be able to change as with this change in the network, and after a while, maybe when the overlay was designed, this thing is optimal, but after some time it becomes suboptimal. So, that is one of the problem with overlay. Okay. Connection oriented networks work very fast, but inflexible, so hard to change as per the policy change. These are the issue. So, SDN is basically a solution from best of the both the worlds. So, packet classification and forwarding part using hardware components, this is done using hardware. Provide traffic engineering by deploying admin rules. Okay. Switch misconfiguration can be changed, again this is an additional thing, none of them provide you this. You will get a global view of the network, not an individual switch view, you will get a global view, you can view network as a single unit. So, switch misconfigurations, loops can be easily checked and validated. Each route for every case can be controlled, and it is also an interesting word, programmable. What does this mean? Now, this is a very critical word. Programmable means you just program this route using an application, an API, you just write a program, you do not need to do it manually. Okay. So, for example, for VoIP, find out the shortest route, list hope route and provide VoIP to that, VoIP packets to route on that, and for data packets find out this route and do it. You will just write a program for it and it will be done every time it is executed. You do not need to do it every time. So, that is the power of programmability. As I said, when this is software driven, the power is programmability. You can program this into an application, that application will continue doing it. Okay. So, programmability is a critical thing. Okay. And the other thing is that programming is done in a higher level vendor neutral open fashion. I do not need to understand the language which is used by a typical operating system or the switch. Okay. His own commands, the typical switch commands or the program commands are not required for me to be learned. So, that is again very important thing. Not only that, this solution is quite dynamic, agile, it can change, flexible and centralized. Okay. So, these are all advantages of having an SDN. Okay. This is the other thing, configuration of network resources in an optimized programmable manner. I have 10 switches, I can allocate switches as per my need dynamically with just click of a mouse. Okay. I am not actually moving one switch from one place to the other, it is automatically done. Remember our virtual network case, I do not need to move a node from one network to the other. In a virtual LAN, I just with a click of mouse I just do it, every switch learns that node to be part of some other network now onwards. The same thing is happening here, I do not need to do it, I will just say that this switch now is part of that segment and it is done. Okay. That is the power. Okay. But then there are other solutions, other things that SDN is trying to answer. First, vendors do provide some solutions actually, okay, obviously, but for their devices and not general solutions. So, vendor solutions are vendor solutions, they are their solutions which are used only for their devices, okay, and whatever is needed for that device is nothing beyond. Obviously, when I build a router, if I am a manufacturer, I do not know what are the requirements of the administrator who is going to use my router. In fact, I have thousands of people who are using my router, everybody has different admin requirements. So, I do not need to know about them when I build my router. So, I won't configure them in. So, that is the problem. The other thing which I can do is I can provide an open interface which let the other person enter that and configure my router as per his admin policy. Now, this is a good thing to do and many good manufacturers of networking devices provide this, but then there is other problem with this. If I have designed one router and somebody else has designed some other router, the problem is that both of them, my solution and his solution is going to be specific to our needs. Okay. What my switch needs, I will provide that, what his switch needs, he will provide that, and will use entirely different interface, absolutely fine. I will not provide something that you want, that also is fine, because I am looking from my point of view, I am not looking from your point of view. So, that is the other problem. Okay. So, what we need is, even though vendors provide this, we would like to have our own additional interface on top of it, which actually can see from the user's point of view and configure device from his point of view. Now, that is here very important, that is what we are talking about. Okay. So, administrator policies are not programmed and not automated as well. Okay. So, we want higher level language instead of a vendor specific language, that is first, and network logic is distributed in multiple switches. Instead of that, network logic should be centralized and should be open. Open means any switch I can manage any switch. Okay. I do not need to have any specific switch. Okay. And I do not need to go to every switch and do it, I should be able to do it sitting on my own machine. Okay. And for a larger network, say thousands of networks, but scattered across hundreds of departments, sitting on your own machine and managing different devices is a great boon. Okay. So, what are the shortcomings of the existing solutions? There are some existing solutions, but then there are problems. Okay. I have already talked about traditional networks and devices like switches, what the problems are, the tight integration is the issue. Need to be configured for higher level policies separately, each switch required to be configured using vendor specific interface, that is the other problem. Different types of devices need different configurations, obviously, because every switch is different, every manufacturer is different. So, his vision is different. Okay. Now, this is something I want when one port is not working, I would like some other port to take over. When one switch is not working, I want some other switch to take over. How can I do it? How can I get that? Now, here is a problem. Okay. If I have got two switches from the same vendor, there is high availability solution I talked about can actually work. When one goes down, the other takes over. But when these two things belong to different vendors, it is very unlikely that they are going to work together. So, this is the other problem. And load balance, for example, I have 10 paths to receiver, and what I want is my traffic should be divided on 10 paths. No routing algorithm, current routing algorithm provide me that answer. OSPF tries to provide, but is not completely random or load balancing kind of. So, what I need is kind of load balancing, all 10 paths should be equally loaded kind of. So, how to do that is also quite interesting, we will talk about that. So, here are the problems of this thing. Okay, now let us look at the three different functions of routers. We have already talked about, so is basically briefing about that thing. First thing is decide the route, and the control plane does that. Okay. Now, deciding the route based on destination is conventional switch job. Based on packet classification is what we want. Second job is forwarding the packet, and that is done by something called data plane. Now, okay, now we are naming these three planes. Participating in network wide management. Okay. So, that I am going to configure my switch for that. So, that configuration part is done by management plane. Okay. Now, we will talk about the division and need for the management plane. You may be data and control plane are two common things, and we can understand the need for differentiating. But why management plane is important? What is the criticality of management plane? The management plane is basically an interface to a switch, which I talked about earlier. And what we want is a consistent interface from a single point of work, okay, to all switches using a higher level language. That is the management interface. Okay. That is the reason why I need management interface. So, controller has the policies built and constitute the control plane. Okay. The data plane deploys the forwarding logic. Okay. Now, here is a question that I would like to ask. Suppose the admin wants to instruct the controller to give highest priority to VoIP calls. Okay. So, all controllers of the network should do this. How will admin do it? Admin do it using a management plane. Okay. That is the interface to controller, please understand this. Or admin may not be able to do it. In fact, admin does not need to do it by just typing some commands. Admin can write an application, and then application will communicate with the controller. So, that can be done in an autonomous fashion as well. So, in fact, that is one of the best things about SDN is that admin, all admin job that he want, he will write a typical network application, and once he will just run that application, the job is carried out. It is very analogous to writing a stored procedure in RDMS. If you know a bit about RDMS, you understand what I am talking about. Okay. How will controller pass the same thing to all forwarding devices? Okay. Controller will talk to switch using something called open flow. This is most common, and there are other solutions also. But then we have two common open interfaces, one from management plane, the network applications that do it with the controller, and the controller to forwarding device. Okay. We need two interfaces, not one, and we will be talking about them, both of them in little more detail in the next module. So, what we have done in this module, what we have looked at, let us brief about the software defined networks that we started looking at in this particular module. The software defined network is a conceptualization where the networks are controlled by software. They are no longer controlled by hardware, they are controlled by software. You can see network as a conceptualization is something which is an abstract thing, and you will be able to look at the network and configure that thing as you want. Okay. Second thing, we have already looked at different types of demands from administrators to route data according to their own wish, their own version, their own wish, and the demands of organization. For example, if you are an ISP, you would like to treat your customers as per the data pack they are connected to. If you are running an institute, you would like to categorize your users. For example, if it is an academic institute, you would like to categorize your users as teachers, operators and students, and you would like to provide services accordingly. So, there is a need of the hour that different categories of customers to be given different types of services. And the conventional routers are designed with two things together, the routing part as well as the forwarding part. The routing part we would like to extend, actually we would like to make sure that routing becomes so flexible, so precise that we can configure it as per our wish. Okay. So, that is one, and the forwarding part is obviously there, and we would like to forward as per this policy. So, that is what we want. One solution provided by SDN is to separate this two things. When we separate these two things, the routers or switches now no longer remain the switches, actually they become forwarding device, and the control part goes to something called a controller. So, we divide our switch into two different parts, a data part which is basically a forwarding part, a switch forwarding logic which forwards a packet from one point to the other, and a control part which decides how those forwarding parts work, or how exactly that forwarding takes place. And you can understand that this demands, if you remember our discussion about packet classification, there is a configuration routine where you insert rules. Okay. So, those insertion of rules actually happen at this controller level. So, controller level they have rules that 2G traffic is to be routed this way, 3G traffic is to be routed this way, the VoIP traffic is to be routed this way, and so on and so forth. So, when those rules are designed at controller level, the other the forwarding layer should follow exactly what is designed there. So, that is a need. Interestingly, there is one more plane, there is one more layer which is actually existing, and there is again a need. For example, every switch, if I want to configure that switch for doing a specific routing job, I will have to go there and install that algorithm and run that algorithm there. Okay. So, that is to be done separately for every switch. I will have to go to that switch and do that job. So, what I need is, when I am separating these two things, I would also like to separate that as well. What I want is, I want a single consistent interface for all different makes of switches, and I can run an application sitting here and which can configure any switch that I want as per my need. I can insert, and if I want to insert some rules about 2G, 3G traffic, I do not need to go to that switch. I will run an application right here which can connect to that particular switch and run. Okay, it can go to that controller and add that rule. Okay. So, I will add those rules. Once I do that, the first part is over. Now, the controllers where these rules are inserted, they will tell the switches to route as per these rules, and this thing is basically programmable. So, when the first layer, when the administrator, when it decides this 2G, 3G, 4G rules and all that, they will just write a program. So, that management plane, they just write a program and start running it, will be given to these different controllers, and those controllers or the control plane will instruct the switches for doing that. So, when switches start doing that, the job is done. Okay. So, the idea is to provide this abstraction. With that note, we will conclude. Thank you.